In the slides for forces, and in particular for static equilibrium, the last example is a bit harder than the others. So I thought I'd do it separately because it might take a bit longer. So the situation is this. There's a traffic light hanging from two wires from two different buildings, and in particular the wires are at different angles from the horizontal. So our job is to figure out the size of the tension force in each of those wires. So, static equilibrium, we're looking for balancing forces. So, let's have a look. Again, if you're comfortable with Math C and you want to do this with I's and J's, go right ahead. I'm going to do it just with two directions, horizontal and vertical. So let's do horizontal, horizontal this way, and then vertical with up being positive. So horizontally, there's a force pulling this direction, there's a force pulling that direction, and the weight force doesn't contribute anything horizontally. So let's do 1 and then 2. T1 is going to be negative because it's going backwards, and we're looking at this component here, which is T1 cos 20. Now what I know is the traffic light isn't moving left or right, so the horizontal component from T1 must be equal to the horizontal component from T2. Those two must be equal. So T1 cos 20 to the left must equal T2 cos 40. The horizontal component from T1 must equal the horizontal component from T2. Otherwise, it would be moving left and right, but it's not. They're in equilibrium. That's one equation involving two unknowns. For me to solve this, I need another equation. And here it comes. Let's look vertically. Again, the traffic light isn't moving up or down, so the total upwards force must balance the total downwards force. Well, the upwards force is the vertical component of T1 sine 20 degrees, and plus the vertical component of T2 sine 40 degrees. That's the upward force, and it is exactly balanced by the weight force, which is 200 newtons. Now I have two equations in two unknowns, and I can solve them. The algebra is going to get a bit messy, but it's not actually that difficult. Problems like this are quite difficult when you have to solve for the angle. Then you need to be clever about using tan equals sine over cos. This isn't that kind of problem, so we should be able to do this. Simplest thing is probably to use substitution. T1 is T2 cos 40 degrees over cos 20 degrees. So now I'm going to substitute T1 in here with this. Let's do it. T1 is T2 cos 40 over cos 20, it's T2, times sine 20 plus T2 sine 40 equals 200. Okay, I need to get the T2s together. Each of these has a factor T2, so I'm going to take it out. T2 times cos 40 sine 20 over cos 20. No, don't want to close the brackets yet. Don't want to close the brackets yet. Plus, that's this part, plus T2 times sine 40 degrees equals 200. Divide by this, and I can tell you what T2 is. It's 200 divided by all that mess. I'm not going to write it again. T2 is, let's solve this, 200 divided by this. Am I in degrees? Let's make sure I'm still in degrees. exit I want. There we go, wrong calculator. 200 divided by cos, wait, let me do this carefully, another fraction, cos 40 sine, let's just make sure it's doing what I want, sine 20 over cos 20 plus sine 40. I'm actually so doubtful about this calculator doing what I want, I'm considering trying again without the fancy fractions. It says 217 newtons. And if I've got T2, then I can substitute that back into here to find T1, because that's 217 cos 40 over cos 20. So that number times cos 40 over cos 20, 177. That actually sounds reasonable. Okay, so I have found the tension number 2 and the tension in number 1.